Next, I'd like to talk to you about what happens when we keep the resistance fixed, vary the voltage, and see what happens to the current. If the resistance is constant, if we increase the voltage, we will increase the current. If we reduce the voltage, then we reduce the current. This circuit is a simple series circuit where I have a resistor, an ammeter, and a voltage source. Here I have the actual layout of that circuit. Here's the source of voltage, and I can change the voltage here by turning this knob. Goes through a resistor, this light globe, through the ammeter, and back over to the voltage source. Now let me turn on the power here and increase the voltage. And let's watch what happens as we increase the voltage. The current now is 0.33 amps. We increase the voltage further, and the current increases further, showing that a voltage increase will cause a current increase. Similarly, as we reduce the voltage, then we also reduce the current. Now, technically speaking, the resistance of the light globe changes with temperature. We're neglecting that for purposes of this experiment. So if we assume that we hold the resistance fixed, increase the voltage, increase the current. Another aspect of electric circuits is the power relationship. Let me turn this up to maximum power. At maximum power, this light globe dissipates energy at the rate of 60 joules per second. It's rated at 60 watts, which means 60 joules of power, 60 joules of energy per second are being dissipated by the light globe, and 60 joules per second are being fed in by the power supply. Power is equal to voltage times current. So if we increase the voltage and also increase the current, that will increase the power, and at a higher power, the light globe is brighter. If I turn down the voltage, also turn down the current, that turns down the power, and now the light globe is not operating at 60 watts, it's operating at a much lower power. If I turn the voltage all the way down to 0, we have 0 volts and 0 amps, and we see that the power would therefore be 0. So no power is dissipated when the voltage is 0. And of course, it's voltage that drives current, but power depends both on voltage and also on the current through this relationship.